Hello. Hello.
Good evening, sir.
Hello. Hello. Are you able to hear?
Yes, sir.
Okay. Okay. Madhurika, madam. Dr. Madhurika,
Yes, sir. Yes, sir.
you can ask them to start the. Hello.
Sir,
Madam, Madhurika, ma'am, you asked that
Yes, sir. Yes, sir.
madam to start.
A very pleasant evening to one and all gathered here. With immense pleasure and pride, I welcome you all to the inaugural ceremony of the AICTE sponsored 6 days faculty development program on advances in biomedical and healthcare using artificial intelligence, organized by Jayashakti Engineering College, Tirunelveli. To begin this wonderful evening, I invite Dr. M. Evi Alice Abigail, Head of the Department of Paramedical Technology, Jaya Shakti Engineering College, to deliver the welcome address and set the tone for the event. Welcome you, ma'am.
thank you, ma'am. Good evening to one and all present here. On behalf of Jai Shakti Engineering College, I extend a warm welcome to our AICTE sponsored 6-day Atal online FTP on advances in biomedical and healthcare using artificial intelligence. It is my immense pleasure to welcome our esteemed guests and dignitaries. Dr. A. Kanagraj sir, Chairman of Jaya Group of Institutions, Engineer K. Navraj sir, Vice Chairman, Jaya Group of Institutions, Dr. K. Deena ma'am, Joint Secretary, Jaya Group of Institutions, Dr. S. Suyambaragan sir, Director Academics, JGI, Dr. M. Somasundram sir, Dean Research, JGI, Dr. P. Tirumurugan sir, Principal, Jaya Shakti Engineering College, Dr. L. Raja, Coordinator of Atal FTP, Mr. K. Sandal Kumar, Co-Coordinator, Atal FTP, respected faculty members, esteemed guests, and participants. I welcome you all to this enriching program, and I hope it will provide a platform for knowledge sharing, learning, and networking. Thank you.
Thank you, ma'am, for your warm and inspiring words of welcome. Next, we are privileged to have with us Dr. L. Raja, Coordinator ATL Online FTP, to deliver the inaugural address. We now request Dr. L. Raja to address the gathering.
Good evening, everyone. Respected Chairman of Jaya Group of Institutions, Professor Dr. A. Kanagaraj sir, Vice Chairman, Engineer K. Navaraj sir, Joint Secretary, Dr. K. Deena madam, Director Academics, Dr. S. Suyambalagan sir, Dean Research, Dr. M. Somasundram sir, Principal, Dr. P. Tirumurugan sir, principals of various colleges of our institution, group of institutions, resource persons of all the sessions, my dear colleagues, and all the enthusiastic participants. It gives me immense pleasure to extend a warm and heartfelt welcome to all of you for the inaugural ceremony of our AICT Training and Learning Atal-sponsored online faculty development program on advances in biomedical and healthcare using artificial intelligence. We are grateful to AICT and Atal Academy for their visionary initiative in sponsoring and facilitating this FTP. Their continuous support is instrumental in fostering a culture of continuous learning and excellence among educators across the nation. On behalf of Jayasakti Engineering College and Department of Biomedical Engineering, I welcome once again you all to this 6 days learning journey. The theme of this FDP is particularly relevant in today's rapidly evolving educational and technological landscape. Our goal is to equip all the participants with the core knowledge and real world applications that are central to advances in biomedical and healthcare using AI. I would also like to extend special thanks to all our distinguished resource persons who will be sharing their valuable expertise with us in the coming days. Their contributions will be the highlight of this FDP. I encourage each one of you to be an active learner throughout this FDP. We believe that the knowledge and the skills you acquire here will not only enhance your professional capabilities, but will also benefit your students and the institution. With these words, I wish all the participants a fruitful and enriching learning experience. Thank you all. Thank you once again.
Thank you, sir, for your valuable insights and for officially inaugurating this faculty development program. Every great event deserves a spark of wisdom and inspiration. We are delighted to have with us Dr. M. Somasundaram, Dean of Research, JGI, to deliver the keynote address. Sir, we cordially invite you to share your insights with us.
Thank you, madam. Am I audible?
Yeah, audible, sir.
Yes, thank you. Respected Chairman, Vice Chairman, Joint Secretary, madam, respected Director, Principal, the coordinators, and the organizing committee, and the participants who have joined. Well, welcome all of you to this 6-day FDP program. I thank all the participants who have registered. I see that participants from all over the country, about 20 states from north, south, east, west have registered. It's a very good, encouraging uh, scene, and we hope all of you will benefit. The FDP covers wide ranging topics by very eminent speakers, touching very advanced topics like artificial intelligence in biomedical research, biomedical engineering issues and challenges, drug discovery, lab equipments, robotics in healthcare, and health informations. So, this is a fast changing field where there is a lot of research going on in the world and in India. And in India, there are agencies of government funding many research projects in this area very actively, like ICMR, Indian Council of Medical Research, DST, Department of Science and Technology, BIRAC, Biotechnology, Industry Research Assistance Council, DBT, Department of Biotechnology. So they are doing a lot of research with a lot of funding in their own organization called intramural and also extramural, meaning funding research for outside research groups and institutions. So that shows that this is a very evolving field where there is a lot of funding is happening. In Jaya Group, we have 36 institutions, and our Jaya Shakti Engineering College is one of the institutions in the Jaya Group. Out of the 36 institutions, 18 HEI, higher educational institutions are there, and including engineering, medical, dental, life sciences, agriculture, and so on. So we have initiated joint research within our Jaya group. Like, for example, engineering with dental, medical, life sciences, and do joint research, joint product development. And there are some startup companies started in our Jaya Incubation Center by the dental, medical, and pharmacy in our engineering-based incubation center. So this shows that there is a lot of potential for interdisciplinary or multidisciplinary research within various disciplines in this fast-changing area like AI in biomedical and healthcare. So, on behalf of management, I thank all of you who are attending this. We hope it will be very useful for you for your future developments in your research, in your teaching, and also the benefit goes to the students who can keep up to the latest trends in this technology. I wish you all the best. Thank you for joining. Thank you.
Thank you, sir, for that enlightening and thought provoking address. Your words have truly kindled our curiosity and enthusiasm for the sessions ahead. Now, it's time to hear from the guiding force behind this grand initiative, the director of Jaya Group of Institutions, Dr. S. Soyambaragan, who will deliver the presidential address. We wholeheartedly welcome you, sir, to address the gathering.
Yes, respected Chairman, Secretary Madam, and Vice Chairman of our Geo Group of Institutions, and the organizers of Jaya Engineering, Jaya Sakti Engineering College. It is one of the group of engineering colleges. And Dr. Thirumurugan, Principal of Jaya Sakti Engineering College, and the I think investigator and coordinator, the main resource for this event is Dr. L. Raja. Without him, this event cannot be organized today. I appreciate all effort put forth by the college, including principal to all the faculties, HODs, and everybody. I think the need of faculty development program is mainly for enriching the teaching strength of the faculties, even though they have sufficient knowledge. Because the nowadays after artificial intelligence came, the total technology, teaching technology, and all the things varied. So that teachers should also upgrade themselves by applying this concept, so that they will be excelling in life. That's what this FDP is organized. Actually, this is the first FDP we got it from AICTE. It's a great achievement. I should appreciate once again Dr. El Raja, Dr. Thirumurugan, and other faculty, the HODs in the Jaya Sakti Engineering College. Also, Dean Dr. Somasundram also constantly motivating this team, so that this have been achieved. So I think there are around 200 plus participants are going to join in this FDB. There are 6 days lectures are there. There are eminent people are going to give the lecture. I think definitely this lecture will be not only our group of institution, it will be worldwide. I think maybe country-wise, nation-wise, participants are there. Their knowledge, their skill, their aptitude in teaching profession will be definitely enhanced through this event. So I thank our management also. Management is very kind enough to help us in all kind of organizing all kind of events, so that our faculty from our group and other colleges and all the group of institutions and the institutions available in India has to develop their career. Because olden days there is a conventional method of teaching. Nowadays all converted into digital teaching, including the artificial intelligence technology. This will definitely be very, very important for the faculties in any institution in the world. Okay, so I think there is a great initiative. This inauguration, I think first day lecture is, I think it will be very useful. I request all the participants to attend all the 6 days and enhance the knowledge in teaching field, so that your profession will be very nice, and so that the students, future pillars of India will be getting benefit through the teachers. Because developing the students to the competitive world, it is a challenge. So all are, I think, very maybe very needed and very cooperative, so that we can develop and build our nation as a best nation among other nations with this type of event, organize this type of events. Once again, I thank our management on behalf. Sorry, I'm thank all the organizers on behalf of our management as a director, and so that I request continually organize such type of events so that our students will have good skills and knowledge when they go out from the institution, not only our institution, students from all other institutions. So thanks once again for this great occasion. Thanks for the opportunity. All the best. Thank you.
Thank you, sir, for your motivating and visionary words. Your encouragement and leadership truly inspire us to aim higher in the field of education and research. Now, I would like to invite Dr. L. Raja, coordinator of this faculty development program, to kindly take over the session and introduce our keynote speakers of the session.
Thank you. Thank you for your well, very good comparing. And I thank all the speakers who have delivered their keynote address. I thank Director Dr. Swebalagan sir. I thank Dean Research Dr. Somasundaram sir and also I thank Dr. Alice for giving the welcome address. Now we are going to continue our session with Dr. U. Sabura Banu Madam. She is the resource person of session 1 now. Madam is available, Sabura ma'am. Have you joined? Okay. Session 1, Madam will be delivering about artificial intelligence in biomedical research. Madam have joined?
Sir, I'm available, sir.
You are inside. Okay, ma'am. Okay. Welcome to this FDP. Thank you, madam, for joining with us. So it is my pleasure to give introduction to Dr. U. Sabura Madam, Sabura Banu Madam. Madam has completed her diploma in the year 1996, and she also completed BSc Mathematics, and she also completed Bachelor of Engineering from Madras University. And Madam has completed her MS by Research in Anna University College of Engineering, Chennai. And Madam has completed doctorate in College of Engineering, Anna University. She's having a vast experience, she has joined in lecturer in the year of 2001 in GKM College of Engineering and Technology, and promoted as assistant professor. And she has worked in professor in B.S. Abdul Rahman Crescent University. And Madam was the HOD of Electronics and Instrumentation in the same B.S. Abdul Rahman Institute of Science and Technology, the Crescent University, which we called shortly. And she also worked in as a professor and head of the department in SRM University, Chennai. And Madam was, when she was working in Crescent University, that is B.S. Abdul Rahman Institute of Science and Technology, she was a IQAC coordinator, and she also director for sponsored research and industrial consultancy at B.S. Abdul Rahman Institute of Science and Technology, Chennai. And Madam currently working as Professor Research and Development at Savita Engineering College, Chennai. And she is also founder and CEO of Intellects Tech at Chennai. And this is a very vast experience, and we are very proud to have Madam with us. And so many achievements she has made in her academic career. And a few I want to mention it now. She has published and received patents, more patents, and she also published the International Journal of 34 and National Journal of 3 and International Conference 77, and her publication in National Conference is 55. And Madam also entitled the books and chapters of 5 numbers, and Madam has guided PG projects of 7 and UG projects of 20, and she has organized various faculty development programs of 10 numbers. And Madam also attended a workshop and seminars of 72. And Madam has organized events of 93 events, faculty development events. And Madam has signed a MOU with various companies. And she has delivered guest lectures of around 90. And she has conducted training and value-added courses and Government of India initiatives. She has incubated startups with NSRCEL seed fund of 20 lakhs during March 2022, continuing as an alumni startup. And Madam has been selected as a mentor of change in Atal Innovation Mission by Nidhi Aayog. And Madam has mentored the project titled Smart Intravenous System, which won IICDC conducted by DST and startup incubated in IIMB. And as an academic leader, she has visited various countries like Dubai to deliver keynote lecture in an international conference on mechanical, automobile, and biodiesel engineering organized by Planetary Scientific Research Center held in Dubai. And she has presented an international conference at London. The conference name is Intelligent Systems. And she has also visited to Malaysia to attend the IEEE control system graduate research uh, organized by IEEE Control System Society Chapter Malaysia. And Madam has received research funds like ARCRES Technosel sanctioned rupees 20 lakhs by DST. And Dr. U. Sabura Banu Madam also awarded a travel fellowship by Center for International Cooperation in Science for attending and presenting a research article and in an international conference held in London, UK. And not only this, her achievements extends to receive awards like academic achievement as an IQAC coordinator. Madam has submitted annual quality assurance report faced by NAC committee during February 2021. As a head of electrical and electronics engineering as SRM, she was instrumental in facing the UGC committee during their visit in September 2017 and prepared the documents for NAC committee. As an innovation partner, she has acted as a jury in internal hackathon for Smart India hackathon conducted in the year 2022 by SRM Innovation and Incubation Center. And she has contributed to research as an editorial board member for the Journal of Instrumentation and Technology and Innovation and Journal of Control and Instrumentation, STM publications. Madam serves as an editorial board member for Journal of Instrumentation, Technology and Innovation. And she has reviewed the book chapter Evolutionary Computation Techniques and Applications by Apple Academic Press and Taylor and Francis. Dr. U. Sabura Banu Madam has served as a reviewer for international journals like Advances in Modeling and Simulation Enterprises, France, Chemical Engineering Communication from Taylor and Francis. And she is a reviewer of leading journals like Applied Soft Computing, Elsevier Journal, and Advances in Modeling and Simulation. And also, she assisted in getting student membership in international and national societies such as ISA USA, IEEE, and Instrumentation Society of India. And she has been recognized in the inclusion of 2,000 outstanding intellectuals in the 21st century in the year 2011 by International Biographical Center, Cambridge, England. And she also recognized as inclusion in Who's Who in World's 2012 issue by Marcus Who's Who Biographical Center. And she was also selected one among top 100 educators in 2011 by International Biography Center, Cambridge, England. She also included in Who's Who in the World 2011 in the 28th issue. And she also mentored the projects and won the prizes like solar panel cleaning, Kabaddi automation, and she also mentored many projects. And as an institutional responsibility, she was IQSC coordinator and a NAC mock committee member, UGC, and many to say about Madam's achievement. And she also contributed to the consultancy and training, like a few I want to mention here. So the list is very long. So by considering the time, I would like to mention few important things what Madam has given a contribution to the consultancy and training. She has completed the projects in 2018 with the National Institute of Wind Energy, Pallikarnai, Chennai, and also conducted training and guided projects for personnel from Apollo Tires. And she has carried out a collaborative projects on neonatal temperature instruments and BMI food nutrition projects completed for International Design and Development Summit in 2025. And Madam also visited Pesto Control Private Limited, and she has given her advice and contribution to many industries. And she has a main partner of accreditation and many more achievements Madam had made. We are very happy and we are very pleasant to have such a great academician with us. And I hope Madam's session will be giving a eye-opening and knowledgeable for the participants. Thanks for the opportunity to introduce Dr. U. Sabura Banu, Madam. I request Madam to take over the session. I welcome you, Madam. Thank you.
Good evening. Am I audible?
Yes, you are audible, ma'am.
Okay, sir. I'll now share the screen. The screen sharing, I'm not getting the screen sharing. Sir. The sharing is not turned on.
Yeah, wait for a moment, ma'am. Yeah.
Is my screen visible, sir? Sir, I have shared my screen.
Visible.
Is it visible?
Visible, ma'am. Visible. Yeah. It is visible.
Okay, good evening to all. So I am Dr. U. Sabura Banu. At present, I am Professor R&D from Savita, and I am also having a company called Aptus Techno Solutions. Today, I'll be covering few concepts in artificial intelligence, and we are going to focus on biomedical research. So initially, what I'll do is I'll just go through the basics of artificial intelligence and the technologies that are used for biomedical research. Then I'll show you few case studies also. First, we'll see artificial intelligence in biomedical research. So what is the need for AI in biomedical research? Now, as we know, AI is gaining popularity, and this AI is going to help us in extract meaningful patterns. So when we say biomedical data, it is we have lot of vast data which is available now, very complex, and again dimensionality of the data which we are having from biomedical field is very uh, high. So we want to apply artificial intelligence so that we can improve on the accuracy and speed of the diagnosis. So even we can directly take up some real world problem and help the clinicians in taking decisions. And again, this AI also is finding a lot of applications in drug discovery. So here, this is gaining a lot of popularity in recent years, and we also can have a personalized medicine. So AI is having a very wide scope in this particular area, and again, we can have a increased efficiency, consistency, and reproducibility. This is not new technology. So even in 1950s to 1980s, that is in mid 1970s, they used a rule-based reasoning system for biomedical research. Later, in after 1990s and 2000, there was a shift from rules to data-driven models. So there were a lot of data which were available, and a lot of statistical learning technologies were introduced, and again pattern recognition were done. And this was again it was a stepping stone of AI in biomedical research. After 2010, all the new deep learning technologies like convolution neural network, recurrent neural networks, and DNNs, they came into existence. And now these technologies are also gaining popularity in biomedical research. And nowadays, in recent year, not only images working separately and data working separately, there is a lot of research availability in the area of combining image text and genomic data. So multimodal learning is gaining popularity in recent years. And again, uh, we are engineers, and this is a entirely different field called the biomedical field. So in biomedical field, the doctors, there is always there is a conflict between the doctors and the engineers. So the doctors, we want them to adapt our technology, but they are hesitant to take up the technology. So we are having a primary role of going for a explainable and ethical AI framework, when we have to make them trust that our technology can be used or it can be a boon for them. So this explainable AI framework is also now gaining popularity. And again, the research at present going on in biomedical research is personalized medicine. And again, pathology and drug discovery. In all these areas, there are a lot of schools. And now we'll see few recent advancements. So 6 days back, there was a report which says there is a company called Takeda, and this pharmaceutical company, they are adopting the AI platform. And here they claim that the turnaround time of 3 to 4 weeks from molecular design to lab testing. So this much fast advancements are coming now. So here, this is a US-based biotechnology company which are checking with Japan Takeda, so that they could bring a they are using this AI technology for pharmaceutical industry, and Sudha Pichai, and in Google DeepMind, there is again a report 4 days back from Times of India. So they are working on immunology. So here, normally for cancer patients, when they are stage 4, we go for immunology. So when they go for immunology, there are every possibility that there are cold tumors. It's an advanced stage, and identification of cold tumors into hot ones. That there is a need for that. So here this particular technology has been first devised, and again it was tested by the lab personals, and they could get a very good result. So this was reported 4 days back, and here you can see another AI point of care devices. So in stethoscope, what they are doing is this was devised by uh, research scholars and faculties from Imperial College London. So they have a stethoscope which will record the ECG and heart sounds, and within 15 seconds they could analyze and they can give some predictions. And again, they have tried with 12,000 symptomatic patients, and the diagnosis, they could diagnose the heart failure, valve disease, atrial fibrillation. So this was again reported in the Guardian. And there is another latest breakthrough, which is by Google DeepMind's artificial intelligence. This was reported only recently, October 15, 2025. And here again, they want to go for creating an immune system so that you can treat advanced stage cancers. So this again is a recent advancement in of using AI in biomedical research. So here there are a lot of data sources. So whenever we say artificial intelligence, it is not having any intelligence of its own. So it requires some data. So the data is a very, very important aspect in any artificial intelligence. So when we say biomedical research, normally the data sources are either it can be an electronic health record, or it can be a genomic or proteomic data, it can be a medical image, or as we saw the stethoscope, we can have a wearable an IoT sensor data. And again, we can also include the clinical trials and biomedical literature. So these are the data sources that are normally used for biomedical research. And the AI techniques normally used that can be used for biomedical research, it is either it can use a machine learning, can use either deep learning, you can use natural language processing, reinforcement learning, and as I told you, explainable AI. It is gaining importance after 2020. So here, uh, we all know human intelligence. We can communicate with people, we can identify patterns in data, can remember things, adapt to new situations. So whenever there is a new situation, we, with our intelligence, we can adapt. And again, we can also take decisions based on the available information which is stored in our brain. Whereas for artificial intelligence, this can also act like a human. Uh, what this will do is it learns from data. So it requires data for doing all the processing. And here also it will learn from mistake, it will adapt, it will backpropagate, it will try to reduce the error, it will try to learn things. So after learning, you will get trained model which can be used for your application. So artificial intelligence is nothing but here you can program and mimic the actions of a human. And here, any machine which is going to work like a human, which is having the capability of learning and problem solving, they are grouped under artificial intelligence. There's nothing but man-made thinking power. So even for artificial intelligence, you have to feed the data, you have to give the algorithm. This is a man-made thinking power. And this is a branch of computer science, all these things you will be knowing. History of AI. So 1943 itself, this artificial neurons came into existence, and now we have deep learning. And again, it keeps on growing. And so in 1956, there was this artificial intelligence word was coined. So this was coined and it was presented in the first academic conference on the topic artificial intelligence. And here, AI have application in almost all the sectors, from gaming to healthcare to transport to agriculture to education to robotics to automotive. It is having application in almost all the domain. And when we see the types of artificial intelligence, you have two types of artificial intelligence. One is based on the capability of the AI, whether it is a narrow AI or a general AI or a strong AI. The Second type of class is type 2, which is having reactive missions, limited memory, theory of mind, and self-awareness. You will see these concepts. So narrow AI, it is applicable only for a simple task. So it will work well for that particular task. Whereas for when you consider the general AI, it will perform just like a human. Super AI, here you have this is intelligent than human. So it will have all the intelligence so that even under some new conditions, it will try to work. And you have your type 2, you have your reactive machines, which is going to work only on current scenarios. So the Google's AlphaGlow and IBM's Deep Blue system, all these things will come under reactive machines. The second type is your self-driving cars. You have a AI in that. So here, if you see, this will have a short memory. So that, and again, to store data only for a very shorter time. So in self-driving cars, we are going to find what are the nearby cars, what are the speed in which the car is moving, how far the car is from your car, and what is the speed limit, and how to navigate the road. So all these informations you will be using in your limited memory type of AI. The third and fourth, theory of mind and self-awareness, it is not in existence now, but there is a lot of research going on this particular domain. So if anyone is interested in doing a PhD or doing further research, you can try this theory of mind and self-awareness. So here we have to understand the human emotions, and again we have to interact with people, and we have to take decisions depending on the social aspects of humans. At present, it is only a hypothesis. There is no AI for theory of mind, but efforts are being taken to develop this particular mission. And the self-awareness, it is very, very smarter than the human brain. It will have its own consciousness, sentiment, self-awareness. It is not available in reality now, but in future, you can expect this. You can also do some research in this particular domain. And when we see the branches for artificial intelligence, we know machine learning, deep learning, we will be saying all these things in detail. Then you have your natural language processing, in which you have your text generation, question answering, classification, machine translation. Whenever we work with text, we it comes under the broad category of natural language processing. Then you have your expert systems, you have your speech recognition where you can convert your speech to text, text to speech and all. Then you have your robotics, you have your vision, computer vision, in which you can either go for machine vision or you can go for recognition of your images. So first we will see machine learning, then I'll move to deep learning, particularly the convolution neural network. Then we'll also see GAN, which is form of generative AI. So all these three things we'll see, and we will also see few applications with which you can apply this AI for a biomedical application. So machine learning, it's going to learn from the past data. So here, when we see traditional programming, we are going to use computer for getting an output, provided you have the input data and you have to give the rules. The expression should be given, data should also be given, and you will be getting an output in traditional programming. Whereas in machine learning, we will be feeding the input and output, and the system should generate the rules. The rules will be generated in a machine learning. Whereas in traditional programming, the rules will be written, the algorithms, the equations, the formula, everything will be written by us. We'll be feeding the data such that we get an output by substituting in that particular formula. Whereas in machine learning, that rule itself we are going to get from the computer. And the different stages you have in machine learning is, first, if you are interested in doing a research in machine learning, first have a question. So define a question. First, you decide on what you are going to work with. Whether I'm going to work with a biomedical data, what type of data I'm going to use, whether I'm going to work with a numerical data, whether I'm going to work with images, whether I'm going to work with signals, whether I'm going to work with text. So first, define the application, where actually which domain I'm going to work, and then you collect the data. So as I told you, the data can be in any format. It can be an image, it can be a text, it can be a number. So first try to collect the data. Once you collect the data, visualize the data, check the nature of the data, what type of data it is. If it is a pure numerical data, you first analyze the different data, whether it is linear, whether it is non-linear, whether it is cubical. So what data it is, whether there is any interrelation between two data sets. So all these things you try to identify and check whether there are any missing data. If it just as we are working with machine learning works only with numerical data, and output can be either categorical or it can be a number. Input side, mostly it will be a numerical data. So first you visualize the data, check whether there are any missing data, whether there are any outliers present in the data. So for that, you have to visualize. You can go for graphical visualization of the data so that it will give a clear picture of the nature of your data. Once you have some understanding of the data, then choose the algorithm, because machine learning, you have hundreds and hundreds of algorithms. So you choose the algorithm which suits your data. Then you go for training the data. So training is nothing but there you're going to feed the data, you're going to give the output, and you're going to get the rules. So once you have trained, when you have the model, so that the output from your model and the output which you have fed to the training, when they are almost same, you can stop the training, and then that model you can use for testing the algorithm. Once you test the algorithm, then what you have to do is you have to collect feedback. And if there is this particular algorithm is not working well, you can refine the algorithm. Maybe the parameters you can change, or you can again change the algorithm itself. So if your results are not satisfying, you try to work on the model. First, you try to change the parameter of the model. If it is not working well, then try some other algorithms. So this is a life cycle for a machine learning. First, I have to gather the data. Then I have to prepare the data. So as I told you, if there are any outliers, if there are any missing numbers, or if there is a not a number, so all those data, what you can do, you can pre-process the data so that it is suited. So your raw data I'm taking, from the raw data, I'm pre-processing the data, I'm preparing the data, then I'm going to send to the next stage of data wrangling. And as I told you, visualize the data, analyze the data. First, you have to have some basic knowledge on what data you're having, whether what algorithm, only if you have some idea about the data, then only you can analyze, you can choose the proper algorithm for your machine learning. So first analyze the data. If there is, take for instance, if I'm having lakhs and lakhs of data, you can go for using principal component analysis for dimensionality reduction. So those things you can do before feeding into the training part. So in training, you have to feed the input and output data, and this will give you a model. Model is nothing but you will be having if you have different types of models, regression model, PM model, Levy-based model, Gaussian progress model. So you have a number of models. So depending on the data which you are going to use, you select the model and then you can train the model. Once you have trained the model, then you can go for testing the model. So if the training model is perfect, or if it is having an accuracy of more than 95%, I can trust the model. Then I have to feed a new set of data, and you have to test the model. Normally, what people do is, if there is a person who's giving a project to you on machine learning, what they will do is they will give you a proportion of the data. So this, take for instance, if I'm having 10,000 data. So I'm giving the project to you. So I'll not give the 10,000 data as such to you. Instead, what I'll do is I'll give some 80% or 70% of the data to you. Remaining, what we will do is we will be using for two different processes. One is testing and one is validation. So here, take for instance, out of 10,000 data, I have given 7,000 data to you. Remaining 3,000 data will be there. What I will ask you to do is, with the 7,000 data, you have to go for training the model. Remaining 3,000 data, what I'll do is I'll give you 1,500 data. You can use that 1,500 data and you have to feed that data to the model you have got and check the accuracy with the testing data, which I have given to you, the 1,500 data. 15% of the data I am preserving for testing. I am giving that data to you. You are going to check whether that particular, you are getting a, if your training accuracy is 95%, your test accuracy should also be at least 90 or 92%. If your training accuracy is 95 or 100%, but your testing accuracy, if it is 50% or 40%, I will not trust that model. You have to go for doing some refinement in the model, and you have to check that, you have to ensure that your test data, you are getting the same accuracy for the test data also. The test accuracy can be 1 or 2% less, but it cannot be very, very lower. So this is a very important step in your machine learning life cycle. After you have checked with the test data, you are giving that model to me. I have preserved some 1,500 data. I apply that data and I'll check whether this model is working for the data which I have preserved. If it is working well, then we can trust that model. Otherwise, I'll return back the model to you and I'll ask you to again retune your model and get a better model. Once you are satisfied with the model, then you can go for deployment of the model. So this is the life cycle for a machine learning. So collection of data is again a very, very crucial job. So there are a lot of repositories available like Kaggle, Manly, UCI, machine learning repositories. This gathering data is again, you have to keep in mind that you cover utmost data. So in all possible combinations you have to consider, and you have to collect the data and you have to start working on the data. So once you are, you can take up this work also. I have a few problem statements. So in Siddalis, it is having quite a lot of applications. In India, we have experienced, even for snake bite, there is a Siddha medicine which can cure the snake bite. So here, the person who can, the botanist who can identify that particular leaf, it's not, we are not having that many persons. So we can have a database. We can collect the images of the Siddha leaves with a label. So if you go to some hilly places and if you ask persons over there who's having an experience, those leaves can collect images, can gather the data. You can Similarly, you can collect data. So you have to collect those data so that it covers the entire range. So that again is the, and again you can also contribute that to Kaggle or other machine learning repositories. So here, whatever I have showed before, I have given in detail. And when you classify the machine learning, you have supervised learning, and reinforcement learning. So unsupervised, I'm not going to give any desired output, just I'm going to give the input data alone. I'll ask my machine to classify, that is unsupervised learning. In supervised, I'll feed both the input as well as output, or data and the labels. So that is your supervised learning. In reinforcement learning, I'm going to reward for the actions. So if the agent is going to work properly, I'll be rewarding them. or otherwise, if they are not acting properly, I'll be giving penalty to them. So this is the reinforcement learning. So these are the different algorithms you can see. So in machine learning, you have your unsupervised learning. In unsupervised learning, as I told you, you can go for dimensionality reduction. Take for instance, if I'm having 1 lakh of data. So when I have 1 lakh of data, if there is any redundant data, that is, if there are some similar data, unnecessarily, I need not waste my memory and time for working on all the data. So what I can do, I can cut on the data. If the similarity is high, what I can do, I can reduce the number of samples. So that is your dimensionality reduction. And one more unsupervised learning, clustering will come under unsupervised. Take for instance, I'm giving a bowl of fruits to you. I'm asking you to classify with experience. What I will do, you will check the color or check the size and take for instance, I'm giving a basket in which you have some 5 bananas, 4 apples, and 3 oranges. What you can do, depending on the shape, color, and size, minor axis, major axis, you can group them. So that is called clustering. So you can go for clustering. For clustering, you will not have any output data. You will have only the input data, the bowl of fruits. That is the input data. You have to group them under apple, orange, or banana. So in that case, if output is not given, you can go for clustering. And in supervised learning, you have two type of subdivisions. One is classification, another one is regression. Take for instance, again, the same fruits. So I'm specifying that the major axis, minor axis I'm giving. And again, I'm giving one criteria as color. I'm giving the uh, diameter, all those informations I'm giving. So I'm also specifying that the output is apple or banana or orange. Then that comes under classification. With the input as a number, output as a label, we call that as a classifier. And in supervised learning, again, when input is number, output is also number, you call it as regression. Recently, we did a project with National Institute of Wind Energy. In that particular project, we are asked to go for short-term and long-term prediction of the wind energy. So here they are having wind power stations in Kaipar. So they want to estimate what is going to be the power that is going to be generated in the next 24 hours. So they have to correctly give that number so that they are from grid, they'll be collecting they'll be saying that this much energy power is required from grid. The others will manage with the windmill. If they are not going to properly give the value, then they have to give penalty, it seems. So for that, both my input as well as output, both are going to be number. In that case, it is going to be a regression model. If my output is going to be label, input is going to be number, it is going to come under classification. If both input and output are going to be number, then we call that machine learning model as regression models. The other thing is the reinforcement. So playing chess, the computer, in all those cases, we'll go for a reinforcement. So here, some new environments, new situations will also come into the picture. So I have to address them. So here, reinforcement learning, we will be working with both awards as well as penalties. So here you can see. So as I told you, I have a set of data. Now first we are visualizing the data. Then here, this is an unsupervised learning. As I told you, take for instance, if it is fruits, apple, orange, banana, there are 3 classes. So you have to have some idea about the data. So better have an idea about the data before working on models. So in this particular case also, I have some idea. So here first I'm visualizing the data. From the data, I can either group them under 2 clusters. So this can be one cluster and this can be another cluster, or I can have 3 clusters. First group, second group, and third group. So I have some idea. So here what I'll do, I'll go for grouping them. Whichever is closer, I'm grouping under one category. So this I'm again categorizing under second category. This I'm categorizing under third category. So here this is so I'm not giving any input, sorry, output. I'm just giving the input and I'm visualizing, I'm analyzing the data, and then I'm specifying. So here I'm specifying I need three clusters, three groups, or three partitions. So after that, I get my groups. So here, this particular technology can be used for genomics application. So depending on the genetic similarity, you can group individuals. And here, these are few other applications of unsupervised learning. So again, for signal processing also, you can take, for instance, if there are speakers and if there is, now we are having the cracker sounds. So if you want to, I can build my own unsupervised learning such that it will isolate my original voice and it will remove the noise. So even if there are a lot of crowd or the sound which I am having now, the cracker sound, uh, this will just separate the speaker one, speaker two voice alone. It will remove. So it is again an unsupervised. So here, independent component analysis used for separating original signals from the combined signal. So you have a number of unsupervised learning like K-mix clustering, Gaussian mixture model. You have hierarchical clustering. So here, all are basically a clustering technology. So you have your PCA. This is another class of your unsupervised learning where we will be reducing the dimensionality. So if there are redundant data, if the similarity is high, you can remove those data so that the number of samples you're going to have for processing in your machine learning, it will be reduced. So this algorithm, next comes your supervised learning. So in supervised learning, here we will be giving both the input as well as output for our training the model. So it again has two categories. One is classification, another one is regression. So here you can see a very simple example. So here sea ice extent in Arctic Ocean. So here you can see the year, and here you can see whether it is a supervised or unsupervised. First, what you can do is you can just plot the data and visualize the data. Here again, I'm visualizing the data. So here I'm using different techniques so that I get a fit of the data. So I want to draw a line such that it passes through all the data or at least maximum data. So this is your regression model. Here, as I told you, for regression, my input is going to be a number, output is also going to be a number. Both are real value number. Whereas you can see for classification, my input, even though tumor size is a number, input is a number, output is going to be a class, whether it is a malignant breast cancer or a benign breast cancer. So whether it is healthy or whether it is cancerous. So in this category, I am going to have my output as a label. So this is your classification model. So here again, whenever you go for a categorical or label-based thing, it is called classifier. And here you have a number of classification models like linear regression, logistic regression, decision tree, Neve-based, support vector all those things. I hope you all know. The random forest, ADA boost, gradient boosting trees. So these are different techniques you can adapt for your machine learning. Again, let's come to the reinforcement learning. So in reinforcement learning, given a sequence of state, we are either going to reward or we are going to give a penalty. This can be used for many applications like game playing, robots, or robots in a maze, or a credit assignment problem. So here we'll subject the agent to a new environment, and depending on the action, whether you can take, for instance, the cat is asked to walk, it is sitting, it is asked to walk, and we'll be rewarding if it follows the action. Otherwise, it will be given a penalty. So thereby, it will try to learn. So here, normally reinforcement learning algorithm, it is based on value or policy or model. So here we want to try to maximize the value function. So here the agent will be expecting to have a long-term return of the current state, and the policy based here action will be performed to gain maximum reward in the future. And model based will be creating a virtual model for each environment. And here the agent will learn to perform in the specific environment. And here again, it's an unsupervised learning. Here we'll be giving a reward. And here this is going to be based on sequential decision making. And here time will also play a very, very important role. And here uh, normally the decision, when you compare the reinforcement with the supervised learning, here reinforcement technique, we are going to take decisions sequentially, but in supervised, all the data will be given at the beginning. Environment is not going to play any role in supervised learning. And next, when you see the decision making, here in reinforcement learning, we are supposed to go for a decision making, which is going to depend on the actions. Whereas in supervised, it's going to change for the label is going to change for every decision. But here the labels are going to be dependent on the decisions. And where actually we'll be using the reinforcement is wherever there's a human interaction required, we'll go for reinforcement. Or whenever the environment is going to change, you have to go for reinforcement learning. Whereas in supervised learning, we are going to have an interactive software system or application, whereas the input and output is the data are not going to change. Here example is a chess game, and there the example is object recognition. So normally reinforcement learning, you can apply for robotics or industrial automation, robotics in maze or business strategy planning. And again, here aircraft control. So even if there is a new situation coming into picture, this reinforcement learning will adapt and it will try to work on that particular thing. And now we'll see how we are going to work with machine learning. So here, normally when we see, you have two different phases. One is going to be the learning phase, and one is going to be the testing or the inference stage. So in learning phase, what we will do is, I have a training data. So from the training data, take for instance, I want to classify the cancer cells. So when I want to classify the cancer cells, I have images of the cancer. Now, what I'll do is I'll get the features from the images. So what is the intensity of the tumor, what is the size of the tumor, all those things I'll be getting. And they are the features I'm going to use. So once I have the features, I'll use an algorithm. As I told you, you can decide on what type of algorithm you want to use. So I have visualized the data. I have some idea about the data. So with the idea of the data, I'll choose the algorithm, whether it's going to be decision tree or SVM or MBA or Anabos or ensemble method. So I can select the algorithm, and what I'll do is I'll try to work with the data. I give both the input features as well as I'm going to give the output. So this output I check with the model output if both the outputs are going to be similar, or if my accuracy is going to be greater than 95%, or if it's a regression model, if I'll be finding the error. If the root mean square error is going to be lesser, I trust that model. So once I have got the model, next what I'll do, I'll go for testing the model. So for testing the model, what I'll do, as I told you, from the 10,000 data, I'm preserving some 1,500 for my prediction, for my testing. So I feed that again from the test data. I find out what is the features, and those features I'll again feed to the model. I'll get the prediction. I have to find what is the prediction accuracy. So here also I know the output, model output I'm getting from this inference. So I have to match those two outputs. If they are closely resembling, I can trust on the model. Otherwise, what I have to do, I have to revert back again to the client, and I have to ask them to, to the service provider, and I have to ask them to model again. So this is the learning phase of the inference from the model. So these are the two steps we'll be using for your machine learning. And when I say uh, I have three set of data. One is my training data, second one is my testing data, third one is my validation data. You have different types of preserving the data for testing and validation. So what I can do, I can feed the entire data for your without preserving any data for your testing and validation. I can give the entire data for training. What will happen? You will end up with a problem called overfitting. So this particular data set or my model will work very good for the data I have submitted. But if I'm giving a new data, there's every possibility that my model will not work well for that particular data. So try to avoid that. Next, you have something called the hold out validation. So in hold out validation, what normally we do is out of the 10,000 data, I'm going to preserve, take for instance, 70, 30. 70% of the data I'll be using for training, and the rest 30% I'll be using for testing. So this training data, this is given to me. I can work with the training data, and testing data is not available with me. I'll again, once the model is ready, then I'll go for testing. So here it's predefined. I'm going to specify what is going to be training data and what is going to be my testing data. The other type of validation is called as cross validation. So in cross validation, what we will do is I'll give you 8,500 data to you. Out of the 8,500 data, what you can do is you can, for all the machine learning, all the AI techniques are going to be iteration based. It's not going to work in a single iteration or single run. I cannot get my result. It is all going to work for n number of times till my output and the model output is going to match. I'm going to repeat the process. So all the techniques which I'm going to use are going to be iterative this. So what I'll do is I'm having a take for instance, let's have a very small number. I'm having 100 for my data. So out of 100, what I'll do is I'm giving you 100 data for your uh, modeling. Now what you have to do is out of the 100, you have to specify as what is going to be your testing data. What is the proportion? So take for instance, 20% I'm going to preserve for testing and 80% I'm going for training. So what I'll do is here I'll show you how it works. So here you can see I have out of the 100 data, take for instance, I'm having 10, I have 10 folds. So first 10, second 10, third 10, fourth 10. So I'm having each 10 as one. As it is iteration based, for first iteration, what I'm going to do is I'm going to hold or I'm going to use the first 10 for my testing. Other 90 I'm going to train. Second term, what I'll do is I'll use randomly either fifth or sixth or seventh as my testing data. The rest I'll use for my training data. So a full cross validation in which what we'll do is for every iteration, I have to specify how many folds I'm going to use, how many groups I'm going to split my data. So out of the 100 data, if I'm going to have 5 groups, so each group will have 20 data. So what I'll do, first 20 I'll have for the first iteration as testing data. Remaining 80 I'll use for training. Second iteration, what I'll do is I'll use third set of my testing data. Remaining I'll use for training. So similarly, so this is how we'll be going for cross-validation. Here, because of this particular cross-validation, you can work on all the data for getting your model. Again, you can also guarantee that when I apply a new set of test data, it is in a position to correctly classify it. So this is the beauty of your cross-validation. So again, you have few metrics in your machine learning. So the first metric is your confusion matrix. So this confusion matrix is here. Take for instance, in this particular case, I have few medical records. What are the medical records? I'm having a model. I'm getting an output from the model. So here you can see, here I have 1,200 persons who are sick and 8,800 persons who are healthy. Out of the 1,200, now here you can see this is originally sick and this is originally healthy. Out of the sick, this is the original output, raw output, and this is the diagnosed, or it is the output from your model, from your machine learning model. Now here you can see this is the output from your uh, predictor or from your machine learning or your AI. Now here, out of the 1,200 sick patients, now here it is correctly classifying 1,000 persons as sick, and it is wrongly classifying 200%. They are sick only, but it is wrongly classified as 200. Similarly, out of 8,800 persons who are healthy, 800 are wrongly classified as sick, whereas they are healthy. Now here, this is called the confusion matrix. So what I have to do? If it is sick and if the original result is also sick, if the diagnosed signal is also sick, then you have to find how many are in that particular category. So this number specifies the uh, correctly classified sick persons. This is wrongly classified sick, and this is wrongly classified healthy. This is correctly classified healthy. So here you can see the diagonal element should be having the maximum value. If I'm having 1,200 here, if I'm having 8,800 here, then it means that I'm having 100% accuracy. But here what happened? Here we have few misclassified signals. So here 200 sick persons are diagnosed as healthy, and here 800 were misclassified as sick. Now you have to guarantee that your diagonal element should be having maximum value, and off diagonal value should be 0. You shouldn't have any off diagonal values. Your off diagonal element value should be 0. You should not have off diagonal values, but here in this case I'm having off diagonal values. How will I? So this is for a binary class. So I'm having only sick and healthy. You can have this for any type of, it can even be a multi-class. So here you can have any number of classes. Now I'll show you when we are going through a case study, I'll show you that. Now here you can see how to calculate the performance metrics called accuracy. So for calculating accuracy, what I have to do, I have to add all the diagonal elements, and I have to check, divide by the total number of samples. Here, the correctly classified signals are 1,000 plus 8,000. Overall, I have 10,000 signal. So here you can see I am having only 90% accuracy. Why I'm getting 90% accuracy? Because I'm having few signals which are misclassified. So 200 misclassified as healthy and 800 misclassified as sick. So here I'm having only 90% of my data are classified correctly. Remaining 10% it is not classified correctly. This is one of the performance metrics which is called accuracy. The next type of performance metrics is called the precision. So when you see precision, what you have to do is here, originally the number of sick persons are 1,200, out of which only 1,000 has been classified correctly. The remaining 800 healthy persons are also classified as sick. So here, this is going to be 1,000, which is correctly classified as 6, divided by the total number of sick patients from the model. That is 1,800. So this will give you the precision value. Recall is going to be out of sick, out of the total sick, how much are going to be correctly classified. So 1000 divided by, so you see, when I'm going to add all these things in a row and diagonal element divided by the sum of the total sick persons, that is going to give me the recall. So out of the sick patients, how many did we correctly diagnose as sick? So out of 1200, we could classify only 1000 correctly. Whereas here, out of the patients we diagnosed with an illness, how correctly we have classified that. So here, this is precision, and these are few metrics that we normally find for any AI. When I'm working with your classification, you have to work on all these performance metrics. So this precision, recall, accuracy, all those things should be high. And again, you have something called F1 score. So the formula for F1 score is 2 into precision into recall divided by precision plus recall. So this should also be a high value. Another important terminology is when we use in our AI is underfitting and overfitting. You can see there is a net, and here you can see this particular data, this will not fit inside this net. So this is underfitting. So when I'm going to use a data which is not sufficient for getting a accurate model, we call the data as an underfitting model. Now, I told you I have a set of data. If I'm modeling the entire data, this particular model will work with even 100% accuracy for the data which we have submitted or which we have used for training. But when I'm giving a new data, if it is not in a position to correctly detect it, we call that as a overfitting data. So normally you have to have a perfect balance between the two. You should not either go to underfitting and overfitting. I'll give a very simple example, you can understand better. So here you can see I'm having a group called what animals and another class which is called animals. Now, see here, I have an apple, I have a toaster, I have a cat here. Whereas here, I have 3 dogs here. So here, this is an animal, and here, but it is grouped under not animal. But here, this should come here. What I have done, I'm not having sufficient data for, or I'm having a bad training data set. So here, this will lead to underfitting. Next is here, see overfitting. In overfitting, what we have done, we are saying that it should be not, it should not be a dog which is going to wag its tail. Now, here, this tail, this cat is also having a tail. So here we have all the dog who wag their tail. Now here, when I say this particular data, this is very great on training set, but it may be bad on the testing set because wagging a tail is also one of the feature we are specifying. But what happened? It is not going to so here, uh, this is not, this is for training, it's great. But when I'm going to go for testing, it may not be sufficient. So what you have to do here, you can specify not dogs and dogs. So even if it is having a tail, if it's a 4-legged animal, it's not, this is a cat. So this is not dog. So if I'm going to have this particular category, it is okay, good on both training and testing. So here you can see both training and testing data both are uh, not good. Here, training said it is very good, but testing said it's not good. When I'm going to have this type of classification, both training and testing are going to be good. So here, as I told you, here I'm using a classifier. Here I'm using a hyperplane which is dividing the data. Now here the data are not perfectly matching. Whereas here you see, in this particular case, this is an underfitting problem. This is overfitting. So here, see here, this line is drawn such that it's correctly dividing the two groups. All the blue dots under one category and all the red dots as another category. Now, if I'm going to have a red spot here, what will happen? This is not going to be classified correctly. If I'm going to have a red spot here, it will not classify correctly. Or if I'm going to have a blue spot here, this is not going to. This works only good for the data which we have given. If I'm going to give a new data, which is going to be in between these two ones, it will not be in a position to correctly detect. Whereas here you can see, even though for my training data, one or two data are not falling in that category, even then my output is going to, or my when I'm going to deploy it, it's going to give me a better result. So here the degree is to here bias is high, whereas here variance is high. Now, so far we have seen the basics of machine learning. Now we'll move on to deep learning. So for a machine learning, I have an input. The input can be an image, it can be a music system signal, or it can be a text. So whatever data I'm having, I have to select the features from the data, which is going to be a numerical feature. Then I'm going to use my classification for this is going to be my machine learning tool, and I'm going to get a dog, whether it's going to classify either as a dog or a not dog. So I'm going to get an output. So here you can see I have an input. I am going to have a feature extraction stage. I have a classification stage, and I have an output. Now this feature extraction is going to be done manually. So here I require a human to interfere in the system and to select the feature from the input data. Whereas in deep learning, I'm not going to involve any human. I'm just going to feed the data as such. It can be an image, it can be a signal, it can be an audio, it can be a text. What a signal I'm having, I'm going to just feed it to the deep learning. This deep learning will split my data. First, it will get the features, then it will go for the classification. So everything is going to be built in deep learning. So here you can see for machine learning, a human is involved in getting the features. So a classification step, I can use the machine, and I can use the machine learning technique for getting the classification. Whereas in deep learning, both the feature extraction classification are both going to be done using my computer. So these things I will skip. Deep learning, just I will touch upon the deep learning. So machine learning, we have seen here feature extraction is done manually, but here you can see the pixels are being divided and edges and other features are being taken. And next stage is combination of the edges. Then we are going to get the features. Once you get the features, then we are going to combine the features and we are going to use it for getting the output. So, but in machine learning, I have to do the entire process by a human person. Here you can see pixel values detected, edges identified. Then you have your combination of the edges. Then you are going to go for identification of the features, and then you are going to apply it for getting the features and getting the output. Now, here for deep learning, so far we have seen machine learning. In deep learning, again, I am going to use a large unlabeled data. So I'm going to use a model, train the model. Then I'm going to test it. I'm going to apply the new data. I'm going to get the required output. So what are the steps that we are going to have in deep learning to identify the objects in the image? You can see initially I'm feeding a image as such. So from the image, it has to get the different features and it's going to make some predictions. Now here, the input layer is going to be the pixels, the image. You will have a number of hidden layers. Finally, you will have an output layer. From the output layer, you will get your class or label. Now, here in deep learning, you have four important concepts. So the first one is the convolution layer. Second, you have your ReLU layer. Third one is a pooling layer. And fourth one is your fully connected layer. So from the first step, I told you convolution layer. Convolution is very important. We are going to use convol. So if you have studied digital signal processing, let's study something called a filter. So this filter, we are going to convolve on the input image and we are going to get a output image, which is going to be a few featural image. Now here you can see you have different filters. So if I want to have the vertical edges or horizontal edges, you have different filters. So whatever feature you want, you have to perfectly convolve that particular filter. So here I have used a filter 101010101. So this is a filter I have used here. So when I'm using such filter, I get an output which is going to, you can see it is somewhat embossed and it is in grayscale. So this I'm getting just by convolving using the filter 101010101. Now, you have, as I told you, you have in convolution layer, you have three important stages. First one is the filter. Filter is something that is a small matrix. And here, I have a image. Take for instance, I have an image. This is a size 255 by 255. And for the RGB image, I am having three different layers. So for red, green, and blue, I have three different layers. Now, what I'm going to do is, this filter is going to be a small normally it will be a odd matrix, and depending on what edge we want, whether we want the beak or eye or the textual information. So depending on what is structured, I will be selecting different filters. So the filters will be getting information such as edges or textures or patterns. All these informations I will be getting just by convolving my original matrix or my original image matrix with a small matrix called the filter matrix or which is called the kernel. Now you have a step size. The next step you are going to have the convolution layer is called the stride. So the stride, what we will be doing is here I'm going to move them because my original image size is 255 by 255. I told you. Now I have a filter which is going to be either 3 by 3 or 5 by 5 or 7 by 7 or 9 by 9. Now, first what I will do is first 9 elements, first three rows and first three columns, I'll be convolving and I'll get my resultant. Next, what I have to do, I have to move the filter so that it covers the entire image. So I'm going to move the filter. I can either move by 1 pixel or I can move by pixels. So the stride is nothing but this is going to give me how many pixels I'm going to move at a time. Next is when I'm going to convolve, what will happen if my original size is 255 by 255, the resultant image will be 253 by 253. So here I have to pad with because the size after convolution the size will be reduced. So either I can work with a reduced size or otherwise what you can do, you can go for padding with the nearby pixels or zeros or ones so that the matrix size 255 by 255 I can retain that. So padding operation is also required in the convolution layer. So filters are required. Stride is another important parameter through which you can specify how many pixels you are going to move for collecting your output, and then padding. If the size is automatically when I'm going to convolve, my size will be reduced. So if I want to regain my original size, I have to go for padding. And next is you have initial convolution layer, which will detect in the diagram itself I showed you. Initially, it will be detecting the edges and corners. Then it will identify simple textures also. In the intermediate, I'll be combining the features so that I can find whether it's an eye or a beak or with a bird, eye, beak or feather. I have to combine simple features so that I'll get complex patterns. Then I can also go for identifying the shape and parts of the object. Finally, you will have the deeper convolution layer where you can identify the entire object and recognize the pattern. So here, as I told you, for detecting edges, you have different kernels. So this is a kernel which you can use for getting the horizontal edge. For vertical edge, I have to use a filter like this. So for each and every feature you want, you have separate filters. You can use those filters and you can get those features. So here again, for corner detection, you can use a filter. Texture, you have another type of filter. For getting shapes like eyes, beaks, feathers, you can use appropriate filters. So once you have convolved, next what you have to do is you have to go for applying to the ReLU function. This is the ReLU activation function. So ReLU activation function is a nonlinear function. So here you can see the values which I'm going to get below 0 to be truncated to 0. After 0, it is going to take whatever value I'm going to get. So this is your ReLU. So if it is going to take a value less than 0, it will be marked as, otherwise it's going to take the corresponding value. So this is your ReLU operation. After ReLU, you have something called the pooling. So here you can see pooling. So here you can see this is again pooling will downsample your image. Initially, I'm having 4 by 4 matrix after rectification. Now what I have done is I'm reducing it to 2 by 2. So here you can use either maximum, average, mean, whatever function you want to use, you can use. So here I have used max here. So here 1, 4, 2, 6, out of which 6 is the maximum value. So I have used 6 here. So out of 2, 7, 8, 5, maximum value is 8. So I have used 8 here. 3, 4, 1, 2, 4 is maximum value. 0, 7, 3, 1, 7 is the maximum value. So what I have done, I have downsampled from 4 by 4 to 2 by 2. So here you can see the image. So this is after ReLU. I have ReLU. I have got such an image. I have downsampled it, and now you can see it will just get the edges, corners, and other features which is required for the. So here, as I told you, you can either go for max pooling or average pooling or a global pooling, and next you can go for final step is going to be flattening. So in flattening, instead of having a matrix, I'll convert that into a array of data. And this is going to be, so here the convolution, ReLU, and your convolution, ReLU, pooling, flattening, all those things has happened. So finally, I'll send it to the fully connected layer, which will give me the final output. So here, the flattened matrix of the pooling layer is fed as input to a fully connected layer. And normally here we'll be using an activation function called softmax, and you can go for a multi-class classification also. So here you can see, just I wanted to show you, if it's a low level feature, it will be like this. If it's a mid level feature, you can see somewhat better information. So here, the textual features we are getting, this is a high level feature. And finally, you get the trainable classifier, which will differentiate windows, the walls, the ceiling, the fan, the this is the bed cover. So the different features I'm getting perfectly. So this is a cupboard. This is again another object in the particular room. So all the features we can easily separate using by getting the different features. So low level features, middle level, high level features, and trainable classifier finally. Finally, I can specify what is the object that is present. So again, the same thing, low level, mid level, high level. So if I want to get the eyes alone or nose, so the different features I'll be getting, and I'll be using it for getting my output. So overall, your machine learning, it's a very powerful processing capability, and it's inexpensive because it's going to work only with numbers. And again, I can work with a large amount of data because here just numbers. So I can work with very large amount of data, and even a computer CPU is enough for doing machine learning, and I can analyze any complex big data. Decision making and predictions can also be done with much accuracy. Whereas in deep learning, here I can work with images. So here performance will be improvised if I have more data, and scalability is also possible. And here I'm not going to do any feature extraction. The system is going to help me in getting the features, and this is subset of machine learning, and testing time will be lesser. So subject artificial intelligence, machine learning, deep learning we have seen. So application already we have seen. Now, the difference between machine learning and deep learning. So here, when I'm having a small or medium data set, I can work with machine learning. Whereas when I say image, a single image will have, take for instance, I have a image size of 255 by 255 by 3. It's a colored image, 255 by 255 by 3. So for a single image, I have more than 10,000 of data. If I have some 1,000 data, think the complexity of the data. So here, this is going to work with big data sets. Whereas here, even if it is a 1 lakh data, here, this is going to be much lesser data when compared to the image data which we are processing. So here, it requires even a CPU sufficient for working with machine learning. Whereas for deep learning, I have to go for either GPUs or TPUs. And again, here, feature engineering, I have to do it manually. I have to understand what the features are I require. Say, for instance, I want to get we have done a work on checking diabetic retinopathy of a person by just visualizing the tongue shape, texture, the tongue dimensions and all. So for that, we did a lot of research. So what is the shape of the tongue? What is the major axis? What is the minor axis? What is the color? What is the texture? Whether there is any uh, what happened to the buds and all. So all these features, we have to make a lot of research and we have to collect the features when I'm going to do a machine learning. Whereas if it's a deep learning, I need not have any knowledge on the features. This I can feed the data image and I can get the feature automatically and I can use it. And again, execution, here it may require a few minutes if I'm going to use a CPU. If I'm going to use GPUs, even in few minutes I can get my result. Whereas for deep learning, if I have a very complex data, even I have worked with, I used to work with some 3 or 4 systems simultaneously. Few systems that will run for, we have GPUs. So we used to run for days together to get a result. Normally, I reduce number of pages I am working with. Even then, it takes a lot of time. So execution time is going to be much higher when we work with deep learning. And interpretability, few algorithms like decision tree, you can understand. But in certain algorithms like SPM, boost, we cannot understand. Deep learning, whatever may be the image we are going to give, from the equation which we are going to get, it's not going to be different for different systems. Whereas for machine learning, we can have some uh, understanding of the formula or the expressions we are getting from my model. Whereas for deep learning, it's impossible. So when I have to choose what? So when I'm having a desert training data set, I can use machine learning. When I'm working with images, which is having a large data set, I'll be using deep learning. And when I have features, I have to go for machine learning. If I don't have any idea about the features, I can go for deep learning. And here you have a number of algorithms. In deep learning also, we have few deep learning algorithms. There are a lot of pre-trained algorithms which can be tuned for our application. And training time, it is short in the case of machine learning, but it is very long in the case of deep learning. So deep learning algorithms much better than the machine learning algorithms. And uh, mainly we go for deep learning because when it's very hard for us to manually get the features because it requires a lot of tedious manual work. So again, time consumption is also very high. So in that case, I can use a deep learning where features can be easily obtained from the deep learning model itself. Is also flexible, and here you can go for large amount of data. I want to just give a gist of generative adversarial network. I don't know whether I have time. So what I'll do is just I'll tell you. I'll just go to the block diagram. I'll tell you what is this. So this is again another algorithm which I have been using for the past 3 or 4 years. So generative adversarial networks. So whenever we say a biomedical application, many a times we will not be in a position to get sufficient data for each and every class. So sometimes the disease data image set will be higher. Sometimes healthy image set will be higher. So if I have an imbalance, take for instance, we work with a data set where I had 1 lakh of data. It was a machine learning problem. But when I had 1 lakh of data, out of which uh, a particular class of data. I had some 10 different classes, out of which one particular class was having only some 100 or 200 data. The other classes had 10,000, 15,000, 20,000 data. Now, when we saw the accuracy for the training, we could get the accuracy of 99%. And again, testing accuracy was also very high. But the class in which I had only 100 data out of 1 lakh data, not even a single data was classified correctly. So that particular class was ruled out in my training. Even though I could get a 99% accuracy, that one class, I was not in position to get even one correct or it missed out the class itself. So in that case, what I have to do is I have to upsample my the data in each and every class. Take for instance, if I'm having 100 images, out of 100 images, if I'm having 1090, I'm having one class with 10 images, another class with 190 images. Now, what will happen? Even if the first class, which is having 10 image set, if uh, not even a single, if my model is not in a position to classify that properly, what will happen? Even then, I'll get 90% accuracy, because if it is classifying the other group correctly, I'll get 90% accuracy. So what I have to do, either I have to upsample this from 10 to 70, 80 or 90, or I have to downsample this. Downsampling, what will happen? Maybe again, we saw underfitting, overfitting problem and all. So what you can do is you can go for upsampling. So for upsampling, what I have to do, I have to generate many of the biomedical images. You can see in Mendeley, or you can see in Tableau, or use a machine learning repository. When you try to download the data, many a times we end up the problem of not having sufficient data. So what you can do is you can use generative adversarial networks. Recently, we are working with Baby Cry language translator. We have downloaded data from Kaggle. So for Hungary, we could get some 380 data signals. Whereas for belly pain or for tiredness, we are getting sample only for some 10, 15, 20. So another sample is having 384 samples, whereas one class is having only 8 or 16 or 25. What I can do is I can try to increase the number of samples from 25 to 100 and 16 to 100. So those things can be done using this generative adversarial network. There are a lot of research, there are a lot of variants which have come in this particular category of GAN. So this is coming under the category of generative AI. So here you can see you have two different terminologies here. One is the generator and one is the discriminator. The generator, what will be doing? Discriminator, here again, I'm going to use a convolution neural network. So discriminator will use a CNN, which is a convolution neural network, which we have seen now. So here, what this will do is, this will, I told you, I have only 10 for belly pain. Now, this 10 image set I'll be passing as a real data sample. Now, I have to generate few more signals, which is going to be similar to the belly pain. So here, but I'm having only 10. I want to double it. I want to have 200 samples. So what I'm going to do, the 10 samples which I'm having, that I will feed as a real data sample to the discriminator. So what this discriminator will do is, here you have another block of the generator. what this generator will do is, the input of the generator is going to be a noise signal. It is a random variable. Now, this signal is fed as input to the generator. Now, what this generator will do is, will try to generate a Billy Payne signal. Now, this real data and this fake data will be fed as input to the discriminator. What this discriminator will do is, it will check whether both are similar. If both are similar, or if when we match the two signals, if they are more or less similar, it will say that it is correct. Otherwise, what it will say? It will say that this signal is fake, or it's not true Billy Payne signal. So what it will be doing? This will be fed to the generator. So it will say that you have a 90% deviation, you have 80% deviation. Now, what will happen? The generator will try to adapt the weights and bias and the other parameters such that it tries to give a new signal to the discriminator second time, which is going to resemble that of the real data. So it is again an iteration based. You have to generate signals such that all the signals which are generated, they are similar to the real signal. Until that point, the generator will keep on adjusting the weight and creating new signals. So finally, what should happen? The discriminator should be fooled by the generator. So both the real and fake should be similar. So till then, this process will continue. So that what I can do, I don't have a signal for belly pain. I'm having only signal for hungry, but I'm in a position to get a new set of signal from my generator, which has fooled the discriminator, so that I get 10 new signals now, which can be augmented to the original data set. Instead of 10, now I'm having 20. This 20 can be fed as input to the next set, and I can have any number of signals generated. And this again, it finds application. This is having application in many domain. Even for aging, you have a lot of filters in your mobile or your tab. In all the filters, you would have seen aging and all. So all these things, it is being done only using this GAN type of AI. So this just I wanted to tell you, because this is again another technology which is normally used for biomedical research. So here you can see you have this is similar. This is inverse of your CNN. So here I'll have a input signal. So finally I'll get a generated image, which is going to be compared with the discriminator. So here you can see there is a random noise which is given to the generator. You'll get an output image. Here you have a raw or real input image. So the discriminator will try to match this two. If they are similar, it will send the image is real. So you can augment that to your image set. Otherwise, it will say it is a fake image. And this information will be fed back again to the generator, which will adapt the weight so that it will generate a newer output. And here again, this process continues till all the images which have been generated are going to be real. So here, a readjustment of weight is going to happen till your discriminator is fooled by all the images you have got. So generator will start from random value. It will start to create an image. So this generator image will be fed to the discriminator along with the original real data set. So it will check for the probability of both being same. The result is going to be the discriminator will have only CNN can have any number of outputs, but the discriminator, even though it is a CNN, it will have only two outputs. One is 0, which is for fake, and another one for 1, which is going to be for real or authentic. And discriminator, as I told you, it is going to be standard CNN. The generator is going to be inverse of the CNN. So here it starts from a random noise and it's going to create image. So both are going to optimize and we can reduce the loss and improve the fitness, and we can have a competition in the two network such that the generator is going to generate an image. It's going to fool the discriminator. So I just so here, see here, the first time generator is actually it is a cat, but the generator is generating a random signal. So the discriminator saying that this is a fake signal. Again, we have a similar. It is further improving after many attempts. You can see here also you have just a gist of the cat, but it's not the original cat. So even then, it's showing it's not. It's a fake image. Finally, till the generator gets the original image. This will be continued. So there are a lot of variants. One second. So there are a lot of variants for the cat. So you can work on these GANs also. And so I'll just show you a case study. So here from image to image, emoji, or for image to image translation, you can also use it for segmentation, uh, text to image generation, facial rejuvenation, aging. So all these things you can do with GAN. As I told you, this finds a lot of applications in biomedical research because this will be in a position to generate fake images which is similar to that of the real image. GANs, we have a lot of challenges like cyber threats and again adversarial attacks. It will fool the deep learning architecture itself. So there are a lot of challenges also. But if we are going to use it in a healthy way, this can be a boon to the AI which we are having now. I'll just show you, as we are not having time, I'll just show a case study. So we recently have a paper on skin lesion detection. So here we want to go for finding skin lesions or skin cancer. So here we are using a variation algorithm. Just I'll brief this. So here we are using three different steps. So we are getting the microscopic of skin images. Then we are going to remove the hairs in the skin, and we are going to apply various DL models. Then finally we are going to use AI interpretation. So here you can see this is the data set we have used. And this is the algorithm we have adopted for skin lesion classification. So load input image. Then we are using hair segmentation. For hair segmentation, we are using black hat transform, tanning edge detector, and morphological operation. We have calculated fitness. We are using a optimization algorithm which is based on AI again. And we are removing the hair. And finally, we are getting, you can see here, this is original image. So this is the mask we have used. And here we have removed the hair. And this is the final image without the hair. And here, again, I have to check the performance metrics. Here, mean square error. So PSNR ratio, peak signal to noise ratio, and structural similarity index. So these things we have identified. And this is again classifier I have used. So we have used different types of classifier here. So this is again confusion matrix we have got for the different algorithms. So this is the performance metrics we have got. And these are different graphical representation of real models we have used. So finally, it should be usable by the doctor. So we are using AI interpretability using GradCam. So, which is the significant part which has caused the cancer that we are highlighting, so that the doctors will be in a position to identify it properly.
Dear participants, if you are having any queries, you can ask madam. Participants, are you able to hear? If you are having any queries, you can clarify with madam.
If you have any questions, you can ask me. So due to as we are not having that much time, I had to rush few concepts. So there are a lot of scope in AI in research. If you have any questions, you can ask me now. So this is my contact detail. You can also mail to me when you are free. Do you have any questions?
Participants, kindly note down madam's mobile number. Later on, you can clarify doubt with madam. Okay. So the time is running out. I think we can end this session. Madam,
Thank you, sir. Thank you, sir.
we extend our heartfelt gratitude to you for gracing this occasion and delivering such an insightful, thought-provoking session on artificial intelligence in biomedical research. Your expertise and the examples have not only enriched our knowledge, but have also provided valuable guidance, madam, that we will carry forward in our academic and research areas. Thank you once again, madam, for this gracing this function. I personally thank you. We can end this session.
Stop. Thank you, sir. Thank you.
Thank you, ma'am. Thank you so much. So let us all ready for session 2. Dear all, good evening. Let me introduce the resource person of session 2. Mr. Balasingham is a well-known industrialist. Am I audible?
Yes, sir, you are audible.
Okay. He is a well-known industrialist, researcher, and trainer in robotics and artificial intelligence with more than 12 years of experience in automotive domain. Currently, he is supporting Embryomatics, whose mission is to bridge the gap between academics and industry in the area of industrial automation. He has completed his BE in Electronics and Communication Engineering from Halagappa Chettiar Government College of Engineering and Technology, Karakudi. He has completed his TCS fully sponsored MTech in Automotive Electronics from Amrita Vishwa Vidyapeetham, Coimbatore. With a vast experience in research and community service, he has successfully guided and completed numerous projects that bridge the gap between academia and real-world application. He has worked with major OEMs across the world like Audi, BMW, Mercedes, Benz, etc. Recently, he was awarded by SRM University for his outstanding contribution to the Industrial Automation Society. So I welcome you, sir. I request Mr. Balasingham to take over the session.
Thank you, sir.
Yes, sir.
Good evening, everyone. Hope everyone is doing good.
Good evening, sir.
Good
Thank
evening,
you.
sir.
Thank you. I'm sharing my screen. Please let me know once my screen is visible. Raja sir, can you please enable sharing?
Yeah. Yes, sir.
Hope my screen is visible now.
Yes, sir. Visible, sir.
Okay. Thank you. See, the intention of this session is something to give overview of this artificial intelligence. Sabra Banu ma'am has given in-depth details about the algorithms or whatever the things we are currently using in artificial intelligence area. She has provided more in-depth technical details about performance metrics, the training, how we are creating the models, difference between different algorithms, and what are the difference between machine learning and deep learning algorithms, and about some in-depth about oversampling using GAN. So all those were she has provided in-depth knowledge. So here my intention is to provide the one very basics about artificial intelligence. Those who are very new to the artificial intelligence, how we can get into the artificial intelligence, how we can start using the artificial intelligence, and how the current world is going towards with artificial intelligence, and what will be the future of the artificial intelligence. All those things we will be seeing in this session. So maybe I'll start with uh, my presentation. Maybe ma'am has provided very basics about the artificial intelligence. So I just want to recall about the same thing. So why we started with artificial intelligence, because sometimes back we were doing all those things with the traditional programming. But why we started with artificial intelligence? Because we wanted system that can resemble like a human intelligence. That is a point where we want to go with the artificial intelligence. So what are the things we can get from the artificial intelligence is like something we want to make the system. It has to reason, it has to make the reasoning, reasoning comes with learning, and it has to do some perception, and it has to do some decision making. So all those things we want some system to do on its own. That's why we want to have the artificial intelligence in any of the systems. So as I mentioned, AI systems, how we can want is like it has to think, it has to learn like humans, but it has to operate faster and more consistency. The problem with this thing is that we need a faster performance, because the how we are thinking is like we may take some time to think and take decision, but if it is a system, then it will consider all those things, all those data, and it is able to take the decision faster. But the only challenge there is like it needs more performance, it needs more a performance processing unit. So with that, it can able to take the decisions fastly. How that artificial intelligence works? So basically, it is learning from experience, which we call it as the training with the data. So that is what we can call it as learning from experience. And that model or the trained experience or the trained data, it will adapt to the new information, which means it is able to take the decision based on what it has learned, which means how it has trained, it is able to take new decisions based on the new informations. So in sometimes we will be using artificial intelligence in recognizing patterns in complex data. Maybe it's a kind of symbolic AI which we have used in the very early stages of artificial intelligence. And we need to make some decisions based on the analysis also, which will be there in the some of the data analysis area. And one more very important thing is like when it comes to real world artificial intelligence applications, natural language processing is very much important. Let's take a traditional text to speech conversion or speech to text conversion, and maybe the language translator, those kind of things. We are currently using AI models to make more accurate results in doing these natural language processing models. So all those things are heavily relying on this machine learning. Maybe ma'am has explained about a lot of things in this area of learning, how deep learning is work. All those things are ma'am has explained in the details, but everything depends on the learning or making a model, the AI model. Please interrupt me if you have any doubts at that point itself, so that I can answer immediately, or we can have the Q&A session at the end also, so that it will be whatever is convenient for you, you can do that same thing. Here, I just want to make you understand how that AI is evolved, where it started, and how it is, how we currently using it, and what will be the future of it. Also, we'll be seeing through this single video. Maybe I'll be playing this video.
Sir, your voice is not audible. Sir, Hello. Sir, your voice is not audible.
Sorry, is it video audible?
Video is visible, sir, but voice now only audible.
No, sir, it's I'm not speaking. It's just video audio. You are able to
Okay,
hear?
okay. Yeah, it is visible. Yeah, clearly.
Yeah,
So
yeah.
I guess
Your
you
voice
want to
also
share
audible.
the computer audio, sir, at the time of sharing, so
Yeah, yeah,
that
sir. But is that visible or not? That's what I'm asking. Is it?
I
Are
can we
you?
can see, but we can't hear, sir. That is the problem here.
Sorry. I thought you were hearing it. I did not hear from
No,
anyone.
no
Sorry.
No, no.
Okay.
problems.
Okay.
It
The
happens.
sound also not audible.
Yeah, sure, sir.
Yeah, we can't hear.
ఎక్సర్సైజ్ చేయాలా అంతా మెత్త మెత్తగా ఇచ్చి మేము గట్టిగా
Can anyone please tell how we can attach that video audio to this one?
రాత్రి 12 కి పెడతా మళ్ళీ దీపం అప్పుడు ఉండే వస్తుంది ఉండు
Can anyone hear me? I'm not
ఇది
sure.
మరి అంత టైట్ లేదు చేతులు లూజ్ ఉన్నాయి ఇది టైట్ ఉంది ఇది ఇప్పాల ఇది ఇప్పిన్ లేదు ఇది ఇప్పితే సరే
సార్ రాజా సార్
పొద్దున బయట పోయి నీళ్ళు తెచ్చుకుందామా అట్లా వస్తా టిఫిన్ తెచ్చేసుకుందాం
Sir, you are audible now, sir.
Yes, I'm audible, but I want to share the video audio.
Madam, what is your difficulty?
మీ అమ్మ మొగుడు తీసిస్తున్నారు నాకు నైటీలో అట్లా
I want to share the audio of this video, sir, because you are saying you are not able to hear, right?
Yeah, Tarun, are you able to hear sir's request? Hello?
Please let me know if it is audible. Is it audible now, sir? You are able to hear the audio?
No, sir. It is not audible actually.
Anyone can please confirm?
No, sir. It's not audible. So we can't hear it. It is still same,
audible?
sir. It is still same. We can't hear it. So I guess the moment you share the screen, you can try.
Sir?
Maybe you can try again and reshare. Sir, at the time you can share the computer screen audio so that we can.
Yeah, anyone can please confirm it was audible when I was playing? Hello?
So you are audible, sir, but
No, sir, not audible. Your voice is audible, but video is not audible, sir.
Yeah. Okay. Is there any way to enable this one here? Because I'm running it. I'm hearing it, but
just click on audio, sir. Just in Zoom.
Okay.
Zoom audio option, and there.
Okay.
To share.
There is a microphone. There is an option, sir. Microphone. Just switch to your system audio.
Okay, 1 second, sir. I'm just opening.
Yeah.
Sir, you have to share with audio.
Yeah, yes, sir.
With audioங்கிற ஆப்ஷன் இருக்கு, அதுல you have to share.
Okay, okay, sir.
Sir, if you're not able to share,
Hmm.
You can put it in the chat box.
Okay, sir. Okay.
அது ஒரு ஆப்ஷன் இருக்கும், லாஸ்ட் ஆப்ஷன்.
Or can I share that presentation so that someone can do it, sir, from your side? Yeah, I got it.
Sir, you share, sir. We will do it.
Okay, sir. Last try, sir. Let me know if you are able to hear this one.
Some find it scary. Many find it useful.
Is it audible now, sir?
Yes, sir. Yes, sir. Now.
Okay, sir. Thank you, sir. Okay, I'll start from embed.
Limitations in computing power and the complexity of AI instead of machines following specific life. Algorithms like convolutional neural networks and recurrent neural networks showed remarkable success in image and speed recognition, language processing, and more. But still, the world of AI continued to evolve, and a huge change was on the horizon. Until the 2010s, machines were being developed that could learn from data, identify patterns, and make decisions with minimal human intervention. Since then, though, AI has progressed to the next stage known as deep learning. Instead of machines following specific instructions and programming, deep learning sets up basic parameters or guidelines and trains the computer to learn on its own. Essentially, it encourages machines to think more creatively and take the initiative. This is very difficult, of course, as computers still require some sort of input from humans. Plus, there are complex aspects of human behavior, such as humor, that are extremely difficult to program or for a computer to learn. Currently, a lot of the systems we interact with daily utilize a form of AI known as narrow AI, specialized in carrying out specific tasks. These include everything from internet searches to suggestions of what to watch on Netflix to digital personal assistants like Siri, Cortana, and Alexa.
Alexa, how tall is Mount Everest?
Mount Everest's height is 29,029 feet, 8,848 meters.
With the invention of transformers, which are deep learning models, not robots in disguise, AI has been able to take another massive leap forward in recent years. As an example, prior to the use of transformers, AI used what are known as recurrent neural networks to understand text. RNNs work fine when translating a sentence word by word. But say you want to translate a sentence from English to French. If you translate each individual word and keep them in the same order, it's likely to result in many grammatical errors due to the importance and difference of word order in both languages. Transformers, on the other hand, can track the relationships in sequential data and learn the context, resulting in much more accurate translations. So, if you've noticed that Google Translate has become much more accurate in recent years, now you know why. These transformers, as opposed to Bumblebee or Optimus Prime, were first introduced in 2017 by Google Brain, a deep learning AI team. And since then, pre-trained models such as BERT, bidirectional encoder representations from transformers, and GPT, generative pre-trained transformer, have emerged. Fun fact, The launch of ChatGPT on November 30th, 2022 was so popular that it caused a code red alert at Google. The most up-to-date statistics suggest a user base of over 100 million users. And in June 2023, the website generated 1.6 billion visits. One of the major advantages of transformers is their ability to be pre-trained on large amounts of data. In terms of their application in the real world, they're already proving valuable when it comes to summarizing and generating documents, understanding video, and even biological sequence analysis. Scientists are using transformers to enhance their understanding of the associations between genes, amino acids in DNA, and proteins. This has led to the quicker development and design of drugs. Transformers are also employed to detect irregularities to prevent crimes like fraud, optimize manufacturing processes, provide personalized recommendations, and improve general health care. Of course, the average Joe is most likely to benefit from transformers when using everyday computer applications, including popular search engines like Google and Bing. And with programs like Midjourney, AI is already capable of creating incredible works of art. It's amazing how far AI has advanced in such a short period of time. On the flip side, some analysts think that its rapid progression is a cause for concern. Fun fact, Midjourney was a key player in a 2023 lawsuit aimed at shaping the landscape of AI ethics and intellectual property rights. Artists Sarah Anderson, Kelly McKernan, and Carla Ortiz initiated the lawsuit, challenging the company's use of their artworks for training AI. Interestingly, in July 2023, most of the claims were dismissed. However, the judge permitted the artists to file a new complaint, keeping the door open for further legal developments. As technology continues to evolve, ethical considerations, regulations, and the societal impact of AI remain important topics of discussion. Faster computers, improvements in algorithms, and access to increasingly large amounts of data have advanced machine learning and perception at lightning speeds. High levels of accuracy when performing tasks have led many businesses to adopt artificial intelligence. And some researchers believe that by 2030, AI could take over as many as 20 million jobs worldwide. Whereas in the past, most people thought that we were centuries away from the kind of sci-fi robots seen in movies, multiple studios now suggest that so-called superintelligence could be developed within the next 60 years. And as we move ever closer to creating free-thinking machines, intellectuals are starting to ask some serious questions about how best to use this unprecedented technology. In addition to Elon Musk, Bill Gates, Stephen Hawking, and many other big names in science and technology have expressed real concerns over the rapid progression of AI.
But I think the development of full artificial intelligence could spell the end of the human race.
Musk even went as far as to call it a fundamental risk to the existence of human civilization, more so than nuclear warheads. Musk has also called for organizations developing advanced AI, including his own company, Tesla, to be strictly regulated.
I try to convince people to slow down AI, to regulate AI.
So, should we be concerned? Well, the major fear is not so much that AI will destroy humanity by its own choice, but more that its goals will become misaligned with humans that have bad intentions, resulting in catastrophe.
Now, the thing that's going to be tricky here is that it's going to be very tempting to use AI as a weapon. It's going to be very tempting. In fact, it will be used as a weapon. The danger is going to be more humans using it against each other, I think, most likely.
If you think about AI as a weapon, like a heat-seeking missile, for example, its goal is simply to hit its target. The missile doesn't feel a sense of purpose or emotion. It just knows that it has an end goal and will do whatever it deems possible to achieve it. This could be disastrous for humans, particularly if artificial intelligence identifies barriers where humans do not. AI could potentially outsmart us, or even manipulate us into doing what it deems necessary to hit its target.
Sergeant Taylor, we are this close to winning the war. But the AI are developing a super weapon.
At some point, it could learn to disregard human commands entirely, and even see humanity as an obstacle it must overcome. And, of course, depending on who keeps the AI in the first place and sets its boundaries or guidelines, AI could be developed for evil purposes from the outset. Fun fact, in 2016, Microsoft released a chatbot named Tay. It was attacked by trolls on Twitter, and in less than 24 hours had learned to tweet out racist, sexist, and highly offensive content. Tay was soon removed from the platform, with a reporter from The Telegraph calling it artificial intelligence at its very worst, and adding, "It's only the beginning." It was a good example of how AI can be corrupted. Clearly, there is a need for caution when it comes to AI, and it will take time for laws surrounding artificial intelligence to be passed through various governments around the world. However, at this stage, the technology is already providing crucial services and is proving to be more of a help to mankind than a hindrance. Let's hope it stays that way. Some find
Hope you had enjoyed that video, second part of the video, at least the present and the future. And we have seen how AI evolved from the past and what are the advantages and disadvantages of having the artificial intelligence. Maybe we'll start from there. From that video itself, you might be seeing what is the current state, the present, what is there. So maybe we are talking about large language models currently, maybe ChatGPT and Claude also, which is a kind of large language model. So what we can do with the large language model is like we can do the nuanced conversations, which means it is something beyond the surface level of conversation, or maybe beyond the white or black kind of conversations. So which means we can have the in-depth conversations about a particular thing that we can do with large language models. For that, it needs lot of data to be trained with, and that is how we are able to get the proper conversation or the beyond the surface level conversation or details from them. And we will be using LLM for code writing as well. Maybe we can able to, that is how the current technology or the current market is worrying about also the replacement of or the jobs, reducing number of jobs also because of this particular feature of the LLM. And we are able to get complex reasoning from the large language model. That is why it is more famous currently. And as one of the major thing with the AI is something computer vision, which we can see a lot of things in the autonomous vehicle. There are a lot of features which are associated with autonomous vehicle, which is involving computer vision. And we are using some medical diagnosis also. We are using some computer vision AI algorithms in medical diagnosis also, which is also very much productive in this medical field. And obviously facial recognition also, which is a part of some of the AI algorithms in computer vision. So currently generative AI is gaining that we are able to generate some of the images or videos, which is a kind of how the machines can think beyond the limit. For that, we are using generative AI. And these are the current trends or things which are currently we are able to feel the presence of AI with these things. As ma'am already mentioned, some of the areas about technical details about the core areas in the AI. So you might have seen what is machine learning and deep learning, what is the difference between those two also. One of the major thing in AI is natural language processing, which is still an emerging field where a lot of research is already going on related to speaker recognition or the natural that language or transformation. Those kind of things are still in evolving stage, but there are a lot of research scope available in this natural language processing still, which where a lot of research are working on different AI algorithms to get more accuracy or more more performance in this NLP area. So as we already mentioned, computer vision is how it interrupts. It's basically started from the classical image processing things, and how we can involve the AI algorithms to train the model, and how we can provide some useful information from the images or from the video, that is what it is focused on, the computer vision. So how we can understand the visual information, those kind of things, that is a part of the computer vision. Robotics is very important field in this artificial intelligence, because that is where we are seeing the physical of the artificial intelligence with the mechanical systems, so that we can see humanoid robots or the dog bot. Those kind of things are coming into this robotics field, where we can see how the artificial intelligence is really working in the with the real physical world. So this is something very basic about how AI works. Like everybody is talking about artificial intelligence, but how it works, this is some very traditional or basic approach. What are the things we will do with artificial intelligence? So first we'll start with the data collection, which is a very primary input for any model creation in artificial intelligence. So for that, we need to have a proper data, and we need to prepare the data. It's a kind of, we will call it as a pre-processing those data. That data we will be using it for training, and training we'll be having different algorithms. Based on that, we'll be doing the pre-processing as well. So the end result of the training we'll be getting the models, but that model we will not take as it is, because we need to evaluate that model. That is where testing and validation comes into picture. And you might have seen about in the previous session that there are some different evaluation metrics are there for different algorithms. Based on the metrics only, we will consider that model for the real production world. So performance metrics is very important to consider that particular model into the real world. So that's why training and validation is very important in this stage of this working with or while creating the AI models. And deployment, as I already mentioned, deployment is based on it will be deployed in the real world when we are fine with the performance metrics in the before stage. So where we will be using the data which is not at all involved in the training, which is a real time data which will be feeding it to the trained model. So there is also called a continuous learning, where this model is keep on learning when we are providing the real-time data as well, based on the results it is providing. So that is why the model is keep on updating itself, so that at one point of time the model is a kind of saturated one, so that the accuracy is far more better than the originally at the time of training. Okay, so this is something called a very basic diagram, which will explains you how that the AI, how we are creating the AI models and all. So as I already mentioned, everything starts with the data. Whatever the data we will be having, based on that we will start training the model. And training the model, there are different ways we will be having. And at the end of the training, we will be getting the model, but again that model will provide some output that is also will be adding to the data, so that it is a kind of feedback loop we'll be having. That is why the continuous learning will be happening to the model, and the model is getting improved day by day based on the data which is getting at any point of time. So we have seen how the artificial intelligence works in a general way, but it is having different domains. It is how it is deployed in different domains. So since this entire training program is for healthcare, so we do deploy, or we do have the importance of artificial intelligence in the healthcare field. But we do have the presence of artificial intelligence in different domain, like education, where there will be a smart tutoring, where there will be an AI generated audio and video which will be taking the classes. And still there are some humanoid robots which is even having the same capability to take the classes also. And in finance, there is already kind of stock prediction is there based on the AI models. For that also, there is a different algorithms currently people are using to train to have different models based on the different criterias, based on the different patterns as well. So we do have artificial intelligence in finance also. Obviously, in manufacturing, we do have artificial intelligence in kind of quality assurance, like at the end of the production, we will be making sure that the particular product which is generated is as per the standard or not. For that, we will be having the computer vision, and based on the result only, we will be delivering those product to the we will be considered that it is non-defective product. Otherwise, if you feel anything is defective, then we will not deliver it. So artificial intelligence plays a vital role in the manufacturing field currently, because to reduce the false products during the manufacturing process. Transportation, I will be seeing one video shortly that how artificial intelligence is involved in autonomous vehicle, because making an autonomous vehicle it's a kind of human replacing, because lot of things to be achieved while driving the car or driving the vehicle. So that also we'll be seeing what are the things artificial intelligence doing for this autonomous vehicle. Maybe this is one short video where you will be seeing the AI, presence of AI in the health prediction.
We go to the doctor when we have symptoms, but could AI detect problems many years earlier and predict our risk of disease? Well, that's the holy grail of preventative medicine, and AstraZeneca has now unveiled Milton, an AI tool they trained on medical data from 500,000 people who are part of the UK Biobank. It analysed 67 biomarkers routinely collected during health checks, including results from blood and urine tests, blood pressure, respiratory performance, as well as age, sex and weight. In some of the patients, it also studied 3,000 proteins found in the blood that have essential roles in the body. Milton looked for patterns in the data too subtle to be seen by the human eye. It then used those patterns to identify patients who would go on to develop the diseases up to a decade or more later. Milton was able to predict over 1,000 different diseases with high accuracy, and for 121 it was rated as exceptional. They included dementia, lung diseases like COPD, chronic kidney disease, and some cancers such as those in the bone marrow or the prostate. For a pharmaceutical company like AstraZeneca, it's the blood proteins that are interesting because they could lead to targets for new drugs. But the data is being made freely available to other researchers to develop diagnostic tools.
Today, when we look at human disease and diseases to treat, it is very much near the later stages of disease process. And so it can be very difficult to reverse some of those disease processes. The goal really would be to intervene earlier and to manage disease and to make sure it doesn't progress.
But Milton is so powerful that already some scientists have warned it will need careful regulation to stop it being used by health insurance companies or employers to assess individuals without their knowledge or consent.
Okay, so this is one interesting video which I wanted to show you, because this will tell you how artificial intelligence can, if the current trend, how it is performing also we'll be seeing with this video. Just to think that you are trying to order one vehicle and you are booking one vehicle and the vehicle is reaching you to your doorstep delivery, and without anyone driving that vehicle. So just think about it, and this video will be more interesting for you.
welcome to your new Tesla.
Wow. Okay, so I hope you enjoyed this video. So just think about if you are booking your vehicle and your vehicle is coming to your doorstep without anyone. It's a kind of God's gift, right? By any chance, can anyone tell which vehicle it is? Or who is the manufacturer of this vehicle? Yeah, that's correct. It's Tesla. Okay, so I just want to show this video, and I want to show I want to tell some in depth about this video because how artificial intelligence is used in the autonomous vehicle. So there are different AI algorithms which is deployed because this is not that much easy, because you can see how artificial intelligence is transforming the world with this single video, but this is not that much easy because we do have a lot of processing, a lot of fast processor to be there to be deployed in this vehicle, because there are so many algorithms or so many real-time algorithms running in this particular feature, like object detection and classification, and maybe lane detection is very important here because we need to decide which lane we are currently going, and we need to look into the traffic sign recognition always, and we need to have the obstacle detection and avoidance also, that also be to be running all the time. And we need to have the 360-degree view of this vehicle, which is done using the fusion, sensor fusion, which is lidar input data, radar data, and then camera feed. Based on that, it has to always have the 360 degree view of this vehicle, and it needs path planning, and it needs to have the behavioral prediction. And one more very important thing is like this adaptive cruise control, which is how much distance we need to keep the distance between the before vehicle or the front vehicle, so that we cannot at any point of time, that there should be some safe distance between the before vehicle. So adaptive cruise control also is very important, where we are using AI algorithms, and we need to have this lane charging and merging as well. Whenever we want to change the lane also, we need to decide properly whether that's the right decision to change the lane. And obviously sometimes currently maybe we'll be having some ADAS feature, which is kind of autonomous parking, which also needs without any driver intervention, the vehicle has to be parked on its own, so that also should be there. And obviously you might have seen the steering control. And one more thing is like acceleration and braking control is also very, very important, because in which speed we need to drive this vehicle depends on the environment and surrounding also, we need to decide based on the AI algorithm. So that needs also. And emergency braking also involved here, which means it should be always ready for the emergency braking. It depends on the environment, current condition. It has to be that emergency braking system should be ready all the time. And this is something called real-time traffic analysis, which will be helping, or which is a kind of connected vehicle feature also. Like it has to decide how I to reach the destination with the different paths available, which is a optimized path to reach the destination also, it has to decide. And these much algorithms will be running at all the time for this vehicle to run without a driver. So it is that much complex, but still AI made this possible also. Okay, so now coming to this, what are the benefits we'll be having with artificial intelligence? Definitely the benefits, if you are seeing about the benefits, it's about increased efficiency and productivity. Obviously, with the systems, large number of systems, we can able to produce large number of production. And obviously there will be reduced human error, because since human is not involved, we will be having the reduced human error. And based on the algorithms which we are deploying, we'll be having smarter decision making, like based on the accuracy and efficiency, we'll be having smarter decision making. These are the benefits we can say about artificial intelligence. But on the other side, there are some challenges, so that we have to overcome those challenges in future, so that we can better use the AI for everyone to be in the using it safely. Major challenge which we are seeing, it's like the job displacement or the ethical concerns. Both are very important. Nowadays we will be seeing every day, hearing about the news that there are some different peoples are getting fired from companies based on the AI. But what I would say is like it's not that's correct, because artificial intelligence is, though it is replacing some jobs, it is again producing some more jobs. Equivalently, it is producing jobs also in the AI. So the thing is that we need to learn the AI so that we are able to adapt the AI technology, and we are able to use the AI, so that we will not be outdated. So the suggestion here is like we need to understand and we need to start using the artificial intelligence in our real life. Bias and data privacy risk, yeah, obviously, because data privacy is very important, because if we are doing something, obviously we are not sure whether our data is not shared with anyone. So we need to be very careful about the data privacy, what we are talking to ChatGPT, or what we are doing the large language models, what we are getting them. We need to be very clear, because if data privacy is, if you are thinking there is some data privacy risk, then it won't be good for the future generations as well. The one of the major challenges, like the lack of transparency, because as we already mentioned how the AI algorithms works, it is keep on learning. So at one point of time, we are not sure on what basis it has taken this decision. So that we call it as lack of transparency, because since it is not a saturated model, it is keep on learning model, which means based on some data, it might have learned something and it will be taking decision based on that data, that we are not sure on what basis it has learned it and what basis it is taking the decision. So that we call it as black box issue, because we think that it has taken decision based on what it has learned, but we are not sure on what are the data it has taken for that learning. So that transparency is very important. That is also one of the challenges which we are facing with artificial intelligence. So you might have seen in this video itself the future of artificial intelligence, but these are some of the terminologies which we need to be aware, so that we will be learning those things also, and we are able to use learning those things in future also. So currently, the artificial intelligence, what we are trying to achieve is like human level intelligence, which is not yet achieved, but still we are moving towards achieving it. So that we call it as artificial general intelligence. And one of the problem in the industry, whatever I mentioned about the quality assurance, we don't have that much processing capability in the industry. So which means in some situations we will be using the artificial intelligence algorithms to be running in the cloud, and we'll be sending we will be developing the models, and we'll be storing those models in the cloud itself, and during real time we'll be passing single sample of data to that AI model, and we'll be getting the decision or results from the AI model. So it is considerably taking some delay or latency is there currently. To avoid that one, there is a thing called edge AI, which means we need to have, you might have seen this autonomous vehicle, which means it is edge AI, which means it is all those processing is happening in the vehicle itself, and it is taking decision there. That is what we call it as edge AI. So in industry also, we need to have that much of processing capacity of that processors, and with which we are able to run those complex AI algorithms there, and we are able to take the decisions in the industry premise itself, instead of sending to cloud and getting it back. So explainable AI, as I already mentioned, there is a challenge in this artificial intelligence, which is not that much transparency. To overcome that one, we have explainable AI, where we will be having the transparent and trustworthy models of those AIs. There is something called AI governance, which we call it as responsible AI, where ethical and legal frameworks should be there, because nowadays if you might be thinking that if in ChatGPT you will be seeing this responsible AI, for some situations it will tell you it is not responsible to provide those results. So where you can see those are responsible AIs, which means some security or some as per the government norms, it should not be something disclosed, or something should not be done kind of thing. That AI should not do it. So it has to obey the ethical thing or legal frameworks based on the government orders and all. So for that, it has to trained in that way. It has to know what are the things it has to do. It should be more responsible. So it has to be in that way. And AI safety and alignment with the human values. Obviously, it has to be safe, because if you consider the data privacy, those kind of things also, it comes into picture. So but as long as we want to travel with AI, it should be safe and it should align with the human values. Societal impacts on employment and economy that we have seen here, the job displacement. So, and there is some social responsibilities also should be there. So as I already mentioned, there is an impact on the employment, but there is alternate ways also there to overcome those challenges. Finally, privacy, security, and power structures are also very important. So when we are doing with whatever the data we are sharing with those kind of AI models, it has to follow some privacy regulations, or it has to follow some rules to keep the data safe. It should not be using it for something else also. And our data should be more secure. It should not be, let's take, if I am sharing some personal information of mine, it should be more secure, so that we'll be relying on those AI models in the future also. I think we have come to the end of this session. If you have any questions, please you can ask me.
Participants, any questions or queries you can ask, sir. No questions? You can put it in the chat box also.
So shall I? Am I audible?
Yeah. Yeah, you are audible.
So today I got to know about one good, maybe we can call it as an idiom, that is AI for AI. So that is truly a new thing for me. But I'd like to ask, so this AI for AI, like, yeah, AI, it's really needed for to maintain or to inspect or something to call it as. So do we have anything like that now? Any other field like biomedical or automobile or any other field? Because this is very new. This is highly helpful for us to regulate this AI completely. But do we have anything like that, sir, so that we can enlighten ourselves on how we can regulate this AI at the time of using the AI?
Yeah, thank you for your question. So currently what I would suggest is, like, yeah, there is something whatever you mentioned, but still it is AI with the whatever the current AI trends, it is evolving. So this is not the right time for the AI for AI is not the right time, because this stage is not that much perfect or that much proper for that one to be. So I don't think we can use that one currently. Any further questions?
Any more questions? Hello? Any more questions, participants? Okay. So, uh, uh, any more questions? No questions? Okay. So, I would like to extend our sincere thanks to Mr. Balasingham, Director, Endramax, Chennai, for your session on insights into artificial intelligence. Sir, your contribution is very instrumental in making this online FDP a great success. Once again, I thank you, sir.
Thank you, sir.
Sir. Thank you, sir. Uh, I request all the participants to attend this online FDP for all 6 days without any absence to meet the minimum attendance requirements for certification. I hope all understand. Okay. So I thank all the participants for their active participation. Thank you all. So any coordinators want to uh, say anything, you can share your suggestions here. Otherwise, we can end the session. So you're requested to fill the attendance and feedback, which is sent to your email as well as in the WhatsApp group also. Kindly fill it immediately. And you have to attend for all the 6 days without fail. So I thank the resource persons, Sabura madam, as well as Balasingham sir, for making this occasion a grand success. Once again, I thank all the participants for this wonderful day. Thank you all.